Okay, here we go. All right, so polyatomic ions, I just gave you a list. Let's talk about what they are and how to use them. Polyatomic ions are groups of atoms that have an overall charge. Yesterday we looked at chlorine, and that chlorine has a -1 charge. It's one atom that has one charge. But there are a ton of different groups of atoms that exist that overall have one charge. For example, chlorate, ClO3. That means that this ion has one chlorine and 3 oxygens, and the overall charge is -1. So it basically acts like we had yesterday. It's just that it's a group instead of a single atom. The list of them that I gave you, that of course I don't have up here. Why would I have it? Thanks. There's 70 of them here. These are the common ones. There's more than that, but these are just some of them. And you can see that it has the name and then the formula and the charge. The negative means -1. And these on each side here, these are the same. This is listed alphabetically by name. This is alphabetically by formula, and both will be useful to you when you name and write formulas, which we're going to do in just a minute. You should note that most of these are negative, which are anions. Almost all of them are anions. There's one cation that we use pretty commonly, and that is ammonium, which is right here, NH4. It's got a +1 charge. Otherwise, almost all of them will be at the second half of the formula, the negative side, the anion side. Can I keep that for a while? Thanks. I'll share it when we need to share it, don't worry. Okay, so how do you do it? Let's go with name to formula first. The rules from yesterday still apply, just that where you look for answers is a little bit different. So let's start with something simple like potassium nitrate. As I mentioned a little bit ago, some of you can do this part in your head, which is great, good for you. But if you can't, the first thing you should do is write the ions down. Potassium is +1. You find that in the periodic table. And then all the ones yesterday ended in what 3 letters? Ide, because they're all off the periodic table, IDE. These are ones that don't end in I. There's a few that do, but the vast majority of them end in ATE or ITE. And so you'd look for them. That's the key to say, oh, well, this doesn't end in IDE, it ends in ATE. That means it must be off of this document, which is called the polyatomic ion list. So I want nitrate. I look here for nitrate. It's the upper right-hand corner. It's got a formula, NO3, and it's got a charge -1. The charge will be important for us for crisscrossing. So you write NO3, -1. Obviously, the ones go there, but they're the same, so they just cancel each other out. And the formula is KNO3, potassium nitrate. So the same method as yesterday, the same crisscross method. It's just that you're looking on this document for the ion. It's a polyatomic ion. Okay. And as I mentioned, a lot of those are pretty common. Nitrates are in foods, so are sulfates. If you have a Gatorade here, potassium phosphate is used to preserve it and sodas like that. So we eat or ingest a lot of these things. We use for other things as well. So just gives us more options of things to write down. It's really exciting for you. Oh, I just mentioned this, but let's refresh your memory. If it's Ide, it's off the periodic table. If it's anything else, then it's off of the polyatomic ion list. When it's off the polyatomic ion list, you never change the suffix. Just leave it what it is. So whatever it says on there is your answer. So in that sense, it's a little bit easier. That it's whatever is written here is what you're looking for. Let's try another one. Sodium phosphate. Take a minute and try to find both sodium and phosphate. Note it has an ATE. Oh, hey, good. Look in the right spot. Sodium's in the first column, so it's +1. Phosphate ends in ATE, so it's not phosphide. That'd be phosphorus. That'd be this. It's not that. It is phosphate, which is over here somewhere. And you can see that PO4, it's got a -3 charge. Notice a lot of them are similar. Right below that is phosphite, which is PO3, -3. Or nitrate, nitrite, sulfate, sulfite. Just be careful of what you're looking at. So phosphate, though, is PO4 -3. And you still crisscross just like yesterday. So this 3 goes there, that 1 goes there, don't write the 1s, and you get Na3PO4. Want to try that one? You're going to. Calcium chlorate. Try to write the formula for calcium chlorate. So calcium's in the second column. It's +2. Chlorate is ATE, so you're looking here. Chlorate is, I don't know, somewhere. Oh, ClO3, -1 charge. And you can see there's a minor issue because there's already a number where you want to put that 2. And so if you just wrote this, CaClO3, and had a 2 next to it, it would look like you'd have 32 oxygens and 1 chlorine, but that's not what we're looking for. So to fix that problem, what you do is you put parentheses around the chlorate, like that. And that just means that you've got 2 chlorates or 2 ClO3s as part of your molecule. Okay? As a matter of fact, anytime you have more than 1 of any of these, you need parentheses. I'm going to write that down because it's important. Anytime you have more than 1 polyatomic ion, you need to use parentheses. Even if there's no number there. So if it was like, let's say, the one that always, not to trick you, but the one that always trips up kids is aluminum hydroxide. And I can do this one really quick for you. Aluminum is +3, and hydroxide is -1. But there's no number there. But if I just take my 3 and put it there, and wrote this, that 3 only applies to the H. But really it should apply to both the O and the H, and so I need to use parentheses there as well. So anytime you have more than 1 of these after you crisscross, you should use parentheses. Questions? Feelings? Concerns? Okay. Because I have the mic on, no one wants to talk to me? That's fair. All right, how about going the other way? Formula to name. What you need to remember for formula to name is that even if it looks complicated, there's only ever two things in an ionic compound. I'll say it again. So even if it looks crazy complicated, really an ionic compound only has one thing that's positive and one thing that's negative. So in this case, almost always you can just name the metal because it's almost, unless it's ammonium, then you can just name the first one. So lithium is the first one here. Then you're trying to track that part down. Okay, is there a box for that on the periodic table? No, there is not. And so which means it's here. As a matter of fact, the chances are the more complicated it looks, the more likely you'll find it on this piece of paper, on the polyatomic ion list. So now it's easiest to go by the other side where it's alphabetical. Is that a word? Yeah. Alphabetical?
Yeah. Alphabetical order.
Yeah, that's right. It's a word. What was I trying to say? Alphabet? I don't know. Anyway. Alphabetized. That's a word too. Okay, anyway. Go by the formula, which is, this is SO4, so look for SO4, which is somewhere on this side. It's right there. It's sulfate. So you use that name. Don't change it. Don't give it an extra ending. Just call aluminum sulfate. Or sorry, lithium sulfate. Let's see. What other ones do people hate? Oh, they hate this one. I picked aluminum again, but that's okay. Try to find that and name it. Every time we start this unit, or even later on, people want to put, like, they want to say these things individually. This is one thing, and I'm sure you looked it up and found it, but it's not carbon hydrogen oxide or carbon hydroxide oxygen. Instead, it's just one thing. You got to find it. So everyone, I hope, found the aluminum. And then you look this up here and look at it by a formula. C2H3O2 is a thing. You can find it right here somewhere. Oh my gosh, what if it's not on there? One. Oh, I found it. Found it. C2H3O2 has got a -1 charge. That's not really important. Oh yeah, the charges are listed here for when you crisscross, but the charges don't mean anything for when you're trying to name. You just, even though it has a -1 charge, you still call it aluminum acetate. Again, don't call it carbon hydrogen oxide or sulfur tetraoxide. That's not what we're doing. One more? Yeah, because you haven't done any Roman numerals today, so let's do one of those. AS. Okay, so first metal is copper. And this, ASO4, is called arsenate. Okay, and that's called that a moral victory if you got that far, okay? But it's pretty close, except copper is a transition metal, and transition metals need what? Roman numerals. So you have to make sure that you put them on there, because copper, not that you need to know, but there are two kinds of copper, not kinds, there are two, copper has two charges possible, 1 and 2. And so they have different formulas, so we make sure we tell everyone what we're dealing with here. Excuse me, you can reverse crisscross. That works sometimes. It works in this case. I always cut it in half mentally and then say, okay, well, I've got this thing, and its charge is, I think, -3. Is that right? Did I screw this up? Oh, I didn't. It's -3. Yeah. It's -3, and there are 2 of them. That equals -6. That's this side, the right side. That means the left side has to equal +6 to cancel it out, because the whole thing is neutral. How many coppers are there? 3. So if the whole must be +6, each copper has to be worth what? 2. Or you just take 6 divided by 3, which is 2. So the whole thing has to be neutral. That's what we do there. So this is copper 2 arsenate. What was the noise I made at the beginning?
I'm not doing it.
I don't remember it.
I make it all the time.
Bye.